All right, this begins the live review session for Unit 4. We're going to start back at the very beginning. So how do we write a ratio? So there are 3 girls to every 5 boys. This word 2 is what turns into our colon. And then the order comes the same way, 3 colon 5. So that's your standard ratio form. And then we can write that as a fraction. We can write that as a decimal. And we can write that as a percent. So that's the 4 different ways. So 7 feet to every 2 feet. So 7 colon 2. 7 over 2. As a decimal. And as a percent. All right, solve the proportion. These are going to be algebraic. So that's 7 times 10, which is 70. And this is 5 times x plus 2, which is 5x plus 10. Number 4, if it helps, when you see these binomials, meaning we have 2 things, not 1, put parentheses around them. That will help you with the idea that we have to distribute. So I'm going to get the x's on the same side. I'm going to bring the 12 to the other side. So that cancels out. That cancels out. We have x equals 18. 4x, take away 3 of them, gives us 1. 6 and 12 gives us 18. All right, number 5 is going to be one of those that ends up being quadratic. And the reason we can see that is because when I do my cross products, we're going to have x's that multiply together. That's going to be an easy 18. But when we go here, we have x minus 3 times x plus 4. And that's going to cause us to FOIL. So 18 equals, there's our quadratic. Remember, the middle two terms are like terms. And to solve this, we want it to equal 0. So I'm going to subtract 18 from both sides. And I'm going to get 0 equals x squared plus x minus 30. Now, to avoid factoring, you're going to take that. You can type it right into Desmos. And you're going to type in just this right here. So x squared plus x minus 30. So instead of 0 equals, we're going to say y equals, just like your calculator, you hit the y equals button. X squared plus x minus 30. And remember, we're looking at the two spots that crosses the x-axis. So we have -6 and +5 as our answers. -6 and +5. Remember, we used to get rid of the negative one, but that was because we had some context to the problem. It was representing side lengths. We don't know what these values represent, so we'll just keep both of them. All right, any questions on that front page from those that are joining us right now?
I'm good.
Okay. All right, so this is being recorded, so you guys can always come back, slow it down, pause it, take a look at it again. It's also being written on my iPad, so if you guys just click the answer key link in the Schoology folder, you'll be able to see all this work as well. All right, some proportion word problems. So on Earth, a man weighs 225 pounds, but on the moon, he only weighs 37.4 pounds. So there's the two things that are being compared. We have the man on Earth and the man on the moon. So Earth, moon. If the space shuttle weighs 27,426 on the moon, so that's going to be yellow. How much does it weigh on Earth? That's going to be pink. So this is going to go on the bottom. The yellow is going to go on the bottom because that's where the moon numbers are. The Earth numbers go on top, so that's where my X is going to go. So this is going to be 37.4x equals, this is going to be a big number, and then divide both sides by 37.4, so that'll bring it back down. It should be a big number still. It is a spaceship. I'm just going to round that. This is very important right here. you need to understand that the numerators have to be the same units. They have to be representing the same thing. So it doesn't matter if you have this flipped. It doesn't matter if yellow was on top and pink was on the bottom. It doesn't matter. As long as there's some consistency between the relationship of the numerators and the denominators. Also, this whole fraction represents the man. This whole fraction represents the space shuttle. So we can make sense of why these numbers are both in this fraction and why these numbers are both in the numerator. There's 4 different ways you can set up that proportion, as long as it makes sense with why the numbers are in the same fraction and why the numbers are in the numerators and denominators. A painting is 2 feet tall and 3 feet wide. I'm going to try and stick with that pink and yellow. So 2 feet tall, 3 feet wide. If it is enlarged to a width, so that's yellow, then how tall will it need to be? So I'm going to put pink on top, which is tall, wide. So 2 over 3, 17.5 over x. So about 11.7 feet. You're allowed to compare feet to, let's say, inches, but if the pink was in feet, then the pink has to be in feet in this one. If the yellow is in feet, this would have to be in feet. So if I gave you inches here and feet here, you have to make them into the same units. Okay. In that case, it's usually easier to make everything in inches. If you make everything in feet, then you get decimals. And here's a good explanation of that right here. You find that your watch gains 2 seconds. So it gains 2 seconds every 6 hours. So how many hours will it gain in 3 years? Notice all the units that have changed. 2 seconds, hours. 6 hours, 3 years. So this is going to be the amount of time it gains. Let's do this. Time gained, time that's gone by. So time that's been gained, time that's gone by. So 2 seconds. You can put the units in there if it helps you keep track of them as well. 6 hours. So when I put my X in here, even though it's asking me for hours, it's going to give me seconds. So after that's done, we'll do the work to turn it into hours. However, I cannot put 3 right here because 3 is years. We need a bunch of hours to go here. So how many hours are in 3 years? So 3 years equals 3 times 365. Because 365 is 1 year. So that's 1,095 days. And there's 24 hours in each of those days. So that's 26,280 hours. Now all of our units are how we want them. So that's 6x equals 52,560. Divide both sides by 6. That's 8,760 seconds. So how many hours are in those many seconds? Well, if I divide that by 60, that's 146 minutes. And if I divide that by 60 again, that's about 2.4 hours. So there was a lot of conversion in there. Each of those conversions is its own proportion or its own ratio. I don't think I'm going to give you something that involved, but it is just a good exercise to be able to set that up and understanding the units. Okay. You will have one problem that involves the units, making sure that your units are in the right um, order. All right, number 9. Your class is making a rectangular poster for a rally. The poster's design is 6 inches by 10 inches wide. The space allowed for the poster is 4 feet by 8 feet. So I don't like how it goes from inches to feet, inches to feet. So here's the poster. And the poster is 6 inches by 10 inches. And the space that we have is 4 feet by 8 feet. So we're going to change those feet into inches. So 4 feet is 48 inches. And 8 feet is 96 inches. So what are the dimensions of the biggest poster that we can make? Now, this poster cannot distort. So I cannot turn 10 into 96 and 6 into 48. Proportionally the same. And we can test that because we know that 10 over 6 is not equal to 96 over 48. So it does not fit perfectly. This small rectangle is not a miniature version of this rectangle. So let's see what's going to happen here. I could keep making this bigger. Let's say I double it to 20 and 12, or triple it to 30 and 18. Either the horizontal is going to hit and max out at 96 first, or the 6 is going to keep getting bigger and max out at 48 first. We have to figure out what's going to happen first. So how many times bigger does this poster have to get before this 6 turns into 48? So what we're asking is, six times what scale factor makes it 48? And that answer is going to be 8.
Divide by 6.
Right.
Divide by 6.
Right, Paul. It's just a small little equation. We're going to divide both sides by 6. That means that if I make this poster 8 times bigger, the height of the poster is going to turn into 48. But what will the width turn into? 10 times 8 is going to turn into 80. So it's going to fall short of the 96. If I do it the other way, if I say 10 times what scale factor is going to turn it into 96, x is going to be 9.6. That means I have to make this poster 9.6 times bigger to turn the width into 96, which means that I would have to make the height 9.6 times bigger, which would make the height 57.6 inches, which is too big. We only have 48. So if I keep making this bigger, we doubled it, we tripled it, we can quadruple it. I'm going to hit 8 times bigger before I hit 9.6 times bigger. So we want to make it 8 times bigger. That means that our poster is going to be 48 by 80. And 48 comes from 6 times 8. 80 comes from 10 times 8. Eight is the scale factor we chose. If we would have chose this scale factor, it would have been 57.6 by 96. And we don't have 57.6 available in our space over here. All right, I suggest watching that back. Make sure you have a good understanding of it so you're able to handle that when you see it. Any questions on this page?
No, I'm good.
Okay. I know 8 and 9 were probably the most involved, so you can freeze it right there and take a look at it. Watch it back at your own pace. All right, we're going to skip the next one because I'm not going to make you guys measure anything. And that page is blank. All right, so that was more of our middle school, our algebra work. Let's get into our geometry work here. So use the triangle below to answer the following questions. Which angle corresponds to angle A, which is right here? Notice it has one arc, so that's going to go with D. Corresponds to B. B has three arcs, so does E. And C has two arcs, and that leaves angle F. Does each angle and its corresponding angle... Yes, Paul.
I need a bathroom.
Go ahead, Paul. Does each angle and its corresponding angle have the same measurement? Remember, if we have similar triangles here, corresponding angles are congruent. So yes, and we can see that just by the arcs in them. Now let's talk about side lengths. Which side corresponds to AB? So AB is 4. Notice it goes from one arc to three arcs. So one arc to three arcs is DE, which is 12. CB goes between two arcs and three arcs. So that's going to be 21, which is FE. AC goes between one arc and two arcs. So one and two arcs. So that's going to be DF. Number 8, what is the ratio of side AB length to its corresponding side? So we know AB goes with DE. AB is 4, and DE is 12. So there's the ratio. BC is 7. And that goes with FE, which is 21. AC is 5.
I didn't get that. Could you try again?
AC is 5, which goes with DF, which is 15. So basically, we took these and set them up as ratios with the numbers for each of their side lengths. Are all three ratios equal? Yes or no? No, they don't look the same, but they do all indeed simplify down to the same ratio. Yes. And that ratio turns out to be the scale factor. You can write it in either form, fraction form, or the ratio form with a colon. Write the similarity statement. Now we can kind of just cheat right here, and the similarity statement is right here. We can just take out this 2, because we know that angle A goes with angle D. We know angle B goes with angle E, and angle C goes with angle Actually, let me double check that. Yep. An easy way to see that also is back up here. A, B, C, D, E, F. Any questions on that page?
No, I'm good.
Okay. All right, so this comes from 4.3. To show the two triangles are similar, we need to try and use side, 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 angle, angle, or side, angle, side. Sometimes there's multiple approaches. Sometimes you're stuck with only using one approach. I'm just going to talk through my thought process with this. I always try and use side, side, side first. So I look to see, do I have all three sides of both triangles? And if for this one, yes, I do. I go after the longest one first and pair it up with the longest one. So 34 over 17. Does that equal, I like to go to the shortest one next, so 16 and 8. And then 30 and 15. And those do all simplify down to a scale factor of 2 over 1. So yes, side, side, side similarity works. Here's the scale factor. And it says write a similarity statement. It doesn't matter the first three letters. I will give you the first three letters, and I want you guys to fill in the second three letters. So for this one, I'm just going to put E, F, G. So you have to tell me what angle goes with angle E. Well, I can see that angle E is from the 90 degrees and across the shorter of the two sides. So that would be across the 8. So it's going to go L, K, J.
Hey, Johnny.
Yes, Paul.
You're funny. Yeah, Siri on your phone.
Did you hear Siri go off?
Yeah.
She's always trying to get involved. She doesn't know how to mind her own business.
Yeah.
I know. All right, 16. I do not have all three sides. I have two sides. And I have an angle between those two sides. So that's making me think of side, angle, side. Side, angle, side. So in order for that to work, I need to establish one pair of congruent angles. So that's angle V is congruent to angle X. And then the sides that come out of those angles need to be proportional. So 28 over 14 needs to be equal to 10 over 5. And we could do cross products, or we can simplify both of those. Those both simplify down to 2. So check side angle side similarity works. Our scale factor is 2. And our similarity statement, I'm going to go with TVU goes with UXW. And I'll show you that. T goes with U, V goes with X, and U in this triangle goes with W in this triangle.
Good Johnny.
Yes.
I hear in the wind. I hear it. Someone mowing or not mowing outside.
Somebody's mowing the lawn outside?
I hear a noise.
No, I don't hear anything.
Yeah.
You have good ears, Paul.
Yes, I don't go ears to hear.
All right, so let's look at this last one. I have no side lengths whatsoever. So I need to try and use angle, angle. So the first thing I see is that angle K and angle Y are both 76. So angle K is congruent to angle Y. But L and Z are not the same. So let's see what this third angle is. This third angle is going to be 180 minus 76 minus 41. And I'm hoping that that's 63. I don't want to assume that though, but it is. So that means that angle J is congruent to angle Z. Now you could have done that with angle X and showed that angle X is 41 and said X and L are congruent. You only need two of them. Don't overdo it. So angle, angle similarity works. We can't find a scale factor because we don't know any of the sides. But our similarity statement, I'm going to go L, J, K, X, Z, Y. All right, 18. Now 18 is telling us that these are similar. And whenever they tell us that, we are able to see what sides correspond to each other, what angles correspond to each other, and it allows us to set up proportions to solve for missing sides.
Wait, I have a quick question about 17.
Okay.
Why wasn't angle L proportionate to anything? Like, I mean, I know it was proportional to X, but why didn't we like write it out aside from the
So
similarity?
not proportional, congruent. Angles are congruent. So L is congruent to X. We don't have to show three of them. It's angle, angle. It's not angle, angle, angle. Like side, side, side is three S's.
Yeah.
And we only need to show two of them. If two of them are congruent, because they all have to add up to 180, it's basically assumed that the third one is going to be congruent. So remember, angle, angle, side, 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 they're all shortcuts so that we don't have to show that every single angle is congruent and every single side is proportional. So we're trying to do the least amount of work as possible.
Yeah. Okay.
Okay?
Cool.
So you just pick two that you can find. So for over here, if they want us to find X, I better involve X in my proportion. So X is PS, and I know that PS goes with TW, so 15. So X is going to turn into 15 the same way that 35 is going to turn into 25 because SR goes with WV. Now you might be able to look at those and know which sides go together. I always double check because I don't do that the best in my head, especially if I have to flip and rotate things. And again, since 35 is from the same polygon as X, they are both up top. So 25x equals 35 times 15, which is 525. Divide both sides by 25. We get x equals 21. All right, next one. Find the length of ij and then ik. So basically, we're looking for x and y. So x is ij, and ij I can see goes with lm, and ik goes with ln. So that means 54 goes with 42. So x over 28 equals 54 over 42. And when I set up the next one, it's going to be y over 35 equals 54 over 42. So x is 36. $18.90. Y is 45. So those types of problems are similar to the word problems we did, making sure you understand the relationship between the numerators and the relationship of the numbers in the actual fraction. So those are more like picture problems compared to word problems. I'm not going to do number one. Number one is a quadratic. It's something you'll have to use Desmos for. I'll let you guys practice that. Let's look at number two here. A random sample of 18 students showed that 8 prefer to watch the NFL, 5 NHL, 3 MLBS, and 2 that's Dancing with the Stars. Assuming the data is representative, meaning proportional, how many students would you assume like these? So here comes what we're comparing here. The NHL out of 445, if 5 liked it out of 18. So we are comparing the NHL to the total. So if 5 like it out of 18, how many will like it out of 445? We're assuming that this percentage will be the same because they're telling us that it's representative, meaning it's proportional. So x is about 124. That gets rounded up there. And I think there's a problem like that in the homework quiz today. All right, 3, write the similarity statement for the two triangles. So on the test, I will give you the first 3 letters. Let's go R, S, T. Uh-oh.
Oh, your belly's dying.
I know. So what goes with R? X. What goes with S? W. So it's going to go X, W, Z. Write the extended proportion and identify the scale factor from B to A. So extended proportion means 2 goes with 5, 6 goes with 15, 4 goes with, well, 4 is smaller than 8, so 4 must go with 10. Then 8 goes with 20. That's the extended proportion. And they all simplify down to the same number, which is the scale factor, which is 2/5. And that's from A to B. From B to A means I need to go this way. So I should flip that. All right, find the value of x if the two polygons are similar. So if they're similar, I'm allowed to use proportions. So that means x is going to go with 15. And that ratio will be the same as, now I get to choose. I'm going to use 4 and 10. You can use 8 and 20 because all of those fractions should represent the same thing. So x equals 6.
Wait, can you go back really quick?
Yes. Good. Take a look at that. I'm going to go grab my charger.
You're going, your epic almost died.
All right, do you have any questions on that number 5? Okay. All right, number 6, use angle to show the two triangles are similar. So I see that S and P are the same. Now it's up to me. I could try and figure out what T is and hope that it's 60, or I can find out what M is and hope that it's 85. I just like that I have more room to work up by T. So it is 60. That means that angle T is congruent to angle N. And that's enough to show angle similarity right there. So our similarity statement's going to be STU, and S goes with P, T goes with N, and U goes with M. Use side angle side. Since I have vertical angles here, that means that angle NMP, which is right here, is congruent to angle TMR. I don't know what that sound was.
Where does that sound come from?
I don't know what that was. Maybe somebody joined the video chat. I don't know. So there's our angles. Go ahead.
MP is not parallel to TR, right?
Not that we know
of. Okay.
Nope. If it was, then we would be able to do angle if that's what you're going for. So now we need to say that 9 goes with, well, 9 is smaller than 12. That means 9 has to go with 6. And 12 has to go with 8. So you can do cross products there. You can turn those both into decimals, whatever you want to do. Those both end up being 72. So that does work. So that means that P and M goes with notice P is at the end of the green, the longer side. So that means that's R, T, M. Eight, first show that the two triangles are similar using a method of your choice. Now, RJ, just like now it's telling us that in that scenario, we have parallel sides. But even if we didn't have that, we still have these arcs in here. So pick your favorite ones. I'm going to go K and M, J and O. That's enough for angle. So angle similarity, we now know that the two triangles are similar. Since the triangles are similar, we are allowed to set up a proportion that involves 2x plus 4 and 6. And I'm going to use 20 and 5. And give myself a ton of room there. So that's 120 equals 5 times 2x plus 4. So 120 equals 10x plus 20. Subtract the 20. 100 equals 10x. X equals 10. What is the scale factor? Remember, the scale factor is a ratio of any two corresponding sides. So I already have a scale factor right here. 20 goes with 5. You can simplify that if you'd like and do 4 to 1.
Would that be 1/4 or 4/1, or does that not matter?
If you wrote it as a fraction, the way I have it would be 4/1. It would be, since it doesn't say like A to B or B to A or big to small, small to big, you could have it the other way.
On the quiz, if it's asking for scale factor, would you want us to simplify the answer, like if it's a fraction, or would we be okay with not simplifying it?
Either way is fine. I usually put multiple versions for answers into Schoology, so either way should be marked as correct.
Okay.
Usually you should do simplified. That's usually the first response that I put in. All right, shadow problem. Find the height of the building. So right there, I know this is X. If we know that the person is 66 inches tall. The person's shadow is 8.4, and the building shadow is 103. So you can do that as a picture problem or as a word problem. So the building relates to the height of the person. (103) relates to 8.4. So this is 103 feet, 8.4 feet, 66 inches. So this is going to give us a bunch of inches. So 8.4x equals 6798, which is about 809 inches. That was an exit ticket question. Somebody pointed out that I wrote feet, and I believe it ends up being what, about 67. Yeah. So if you got it marked wrong, I did go back and change your answers. Not that it counts for accuracy, but if you thought you got it wrong, you can check back. 809, or if you put 67 feet, either one of those is correct. All right, number 10, in order to have proper water runoff, a gutter should have a slope of at least 1/40. So that's a ratio. I'm just going to write that ratio down. And we're talking about slope, which is rise over run. So look how much information was given right there. What should the vertical distance be? Vertical difference, which is the rise, if the system must cover a horizontal distance, which is the run, of 25.6. So that's 40x equals 25.6. Which is 0.64, which I'm going to double check that work. That seems a little off. Nope, that's good. All right, number 11. So this comes from 4.4. So how does a scale factor relate to the ratio of perimeters, and how does the scale factor relate to the ratio of areas? Well, scale factor and the ratio of the perimeters are always the same thing. So these two columns are going to be the same. The ratio of areas, however, we have to square that. Now, if we already have the squared version, to go backwards, we have to do the square root. So 10/8. You can simplify that even more and make it 5/4, but 10/8 is fine. It compares it nicely to 100/64. All right, last one. Find the area of the larger triangle.
Hey, Tony.
Yes, Paul.
Last year in math class, tell all the students, you need a math binder and a pencil.
Math binder and a pencil.
In August.
Okay. Find the area of the larger triangle using the relationship between scale factors and the ratio of the areas. So what is the scale factor looking at this? Well, we just need a relationship between two sides, meaning 84 is the only side measurement we have here, and that matches up with 7. So the scale factor is 84 over 7, or 7/84, which simplifies down to 12/1, or 1/12, depending on how you established yours. The ratio of the areas we need to square that and do 144 over 1. The area of the small triangle equals base times height divided by 2, which is 16. And that means that the area of the big triangle is 144 times bigger, since each of the sides is 12 times bigger. So 12 over 1 equals, and don't forget we have to square that. Now we already had that created, so you could go straight to 144 over 1 there. But notice what's happening is it's just 144 times 16, which is 2304. All right, that's the last one. Any questions?
I'm good.
You good?
Yeah.
Thank you.
All right, no problem, guys.
Thank you.
Thank you.
No problem. If you have any questions on if you didn't do the homework quiz yet, remember tomorrow's test, there's no time on when you have to take it. So if you want to go through office hours tomorrow and go over anything and then take your test maybe at the end of the day, you guys do that strategically however you want, okay? Get as much help as you need before the test, okay? I'll see you guys later.